And we're back. Now, I've got the eggs back from rinsing out with water to get rid of the syrup. I'm going to pan this down so that we can examine the egg itself. Here is the egg in the cup. So let me roll this egg out. Now it's been rinsed off. All right, the color, it's been stained by the caramel color in the syrup. It's still a little damp, but as you can see, it is not tight like a water balloon. So we have definitely lost some mass. We have, because the egg was hypertonic and the syrup was hypotonic, we have exchanged the water from inside here to outside into the hypertonic solution. So I'm going to roll this back in. The original mass of the egg when we put it into the syrup was 104.5 grams. So let's just pan you back here to where you can see. There we go. All right, we're watching this line. So I'm going to set this at 104.5. And as you can see, that is way too heavy. Okay. Now, let's just go back and let's start and do some logical reasoning. Well, our original mass of the egg and the cup together was 72.5. So let's set this at 72.5. Now, 72.5 is not heavy enough. So we're not back to the original mass of the egg and the cup. So we haven't drawn all the water out that was originally inside the egg. We haven't lost that mass. Let me just push this back to 0, the ones. Let's run this to 80. Okay, 80 is too heavy. So our mass is now between 70 and 80 grams, and this is just very lightly floating on the bottom down there. So let's go back to 70. Let's take this out to 75. 75, and at 75 nothing's happening. 77, we're starting to come down, but not far enough. Let's go to 78, and it appears we've found the final mass of the egg and the cup together. Now, of course, we can subtract the mass of the cup out and we can get back to the original mass of the egg, which we just might do here in a minute. Let's run this out. 78.2. We'll wait and see if this will balance out. 78.2. Yep, 78. No, let's go one more. Get my pencil here, pardon my reach. Okay, 78.3. So our final mass of the egg and the cup, we went from 104.5 and we are now at 78.3 grams. So let's just do a little bit of math here. 104.5 minus 78.3. 5 minus 3 is 2. 14 minus 8 is 6. 9 minus 7 is 2. We had a loss of 26.2 grams. So over the course of the vinegar and the water, we gained 32 grams. We've lost 26.2. That is a very significant loss. So now we're going to take the change is the change divided by the original. In this case, it's going to be 26.2 over 104.5. Now remember, this is all in negatives, okay, but we're still running the numbers the same. So 26.2 divided by 104.5 is 25%. And that is a negative 25% change, negative 25% change. All right, so down here, the results of the diffusion. The vinegar, the average change for our egg, and remember this was after 24 hours. Now, in the original, let me just pull one here from my class. In the original, we left the egg in vinegar for 2 days, and we went from 78.5 to 107.5 in this particular class for a gain of 29 grams, or almost 37%. When we put it into the water, we actually only gained 4 grams, and that was pretty much universal across the board for all of my 6 classes. So ours was different simply because we did the egg. We did the egg in the vinegar for 24 hours. We did the egg in the water for 24 hours, and then we checked these. So we had pretty much a fairly even increase, 18 and then 14 grams across the board. So about 20 and 15% increases with those two, but then we had this 25% loss over there. So the average change in mass with the vinegar for us was a plus 20%. The water change was a plus 15%. And then with the syrup, we had a decline of 25%. Now our lab continues. There's a page here that asks what were our observations. And then they want us to do a graph. And on this graph, what we're going to do is we're going to graph our original egg, the increases, and then the decline. So if we were to graph this, we would have an X and a Y axis. Okay, X always the bottom because X is time, always, always, always. And then Y is whatever amount that you want to do. So for our particular egg, we'll start with a mass of 50 grams. And then we'll do this in increments of 10, 60, 70, 80, 90, 100, and then 105. And I think we went up to what? Actually, we went up to 104.5 was as high as we went. So we're good there. And then on time, we can do this over 1, 2, 3, 4, 5, 6 days. 2, 3, 5, 6, and our time is days. So our time will be days. Our Y is our measurements in grams. Okay, so the original mass, and we're doing this as an egg plus cup. Okay, so egg plus cup, that keeps all of our numbers the same, so we don't have to worry about changing anything. Our initial was 72.5. So on day 1, we started at 72.5. That was our initial. Actually, our initial needs to be there. This is why I should have been doing this in pencil. 72.5 on our initial. After 1 day in the vinegar, we increased to 90.5. So we had an increase to 90.5. This one is our outlier. It's irrelevant. Okay, so we're graphing. We had our initial here. This was after 1 day, so this was in the vinegar. Okay, so we're going to write in that it was in the vinegar. The next day we went to 104.5. So we'll come up here on day 2. We went to 104.5. Okay, so that's up there, 104.5. This was in the distilled H2O. And then we left it over the weekend in the syrup. So that was in days 3 and 4. We're now on day 5, the morning of day 5. So we came back down to 78.3, and that's here. And this was in the syrup. Okay, so here we go. So this is our graph. We started, we went up. When we had it in the vinegar, we went up. When we had it in the water, and then we had a decline. We had a decline when we had it in the syrup. So if we had to graphically represent that, that would be what our graph would pretty much look like. We would have our y-axis is the grams, our x-axis is the time. This was our initial starting point. Don't worry about that. That's my mistake there because I thought we started on day 1. We're actually starting here. After 1 day is when we measured again. After 2 days was when we measured it. And then we let it go all weekend, and we're coming in here on day 5 and measuring it at the beginning of day 5. So this, and even if you wanted to put this here at day 4, it's still a significant decrease, and we're back down to 78.5. And if I was holding the paper correctly, you would see that that would be across there. All right, so we would write in any observations that we had. We've graphically represented it. Source of any errors that we might have had. In ours, we had some mathematical errors. And then we had some questions. What happened to the size of the egg after remaining in the vinegar? It got larger. Was there more or less liquid left in the cup? Now that we did not measure, and the liquid appeared to be about the same in relationship to the egg, although we know for a fact that some liquid went into the egg. Did water move into or out of the egg? It did, because the egg was hypotonic and the vinegar was hypertonic. What happened to the size of the egg after remaining in distilled water? It got even a little larger. There would have been less liquid in the cup, but not enough that you could have seen it. You would have had to measure it. Did water move into or out of the egg? Yes, it continued to move into the egg because the water, remember the vinegar was 95% water. The water was 100% water, and therefore we still had the egg being hypotonic, the water being hypertonic, and we had that movement across the membrane. And then what happened when we put it in the syrup? Well, of course, it shrank. Was there more or less liquid left in the cup? The liquid, not so much that there was more, but it was watery. It was more liquid, less viscous. Part of that was the sugar molecules dropped to the bottom of the cup, but also we had that water invasion because remember now the syrup was hypotonic and the egg was hypertonic, and we were looking for that isotonic state. Did water move into or out of the egg? It moved out. And why? Because, again, syrup was hypotonic, the egg was hypertonic. And then our conclusions, what did we learn here? We learned quite a bit. And then, of course, here on the back, in our classes today, we'll write out what did we learn. So, there you go. That is the lab. Now, let me just show you, though. I got my 6th hour here. So we have the video egg. Remember the video egg, because I want to show this, really want to show this to you, because we had to come up, we used a different solution for 6th hour. So again, here's the video egg. It's all squishy. Yes, squishy is a scientific word. Here's the egg from 6th hour. You can see that this egg, while soft, is not as soft as that egg. Also, this one does not appear to have shrunk. Now, let's just put this on here for a second. In 6th hour, which I left up on top, their egg came in at 111.5 grams when we put it into the syrup. Let's just see, for grins and giggles, let's just see, put that up there so you can see. Let's just see, let's go to 111. Okay, so 111 is too heavy. We take the 10 off, Still too heavy. Take the 1 off. Still too heavy. Okay. We did lose, but did we lose enough? Go to 80. Go to 90. Okay, 100 is too heavy. So we come back to 90. We weigh this in. 98. All right, so there was a loss, approximately 97.5. So there was a loss $97.5. So we went from 111.5 to 97.5. Their egg actually started at 78. So while we had a loss in theirs, we did not have as significant a loss as we did with the other classes, which were using the straight corn, high fructose corn syrup, pancake syrup mix that we were using. This was the concoction of honey, syrup, and water. So obviously the addition of the water did not make that hypotonic enough to take that out. All right. Hopefully you enjoyed this. I'll have the after the lab put up in the morning when we take the eggs back into the lounge where I have a sink, and we're going to see what's actually inside the egg when this is all said and done. And hope you'll stay tuned for that one.